Good afternoon, dear students. Today we are going to discuss about extrusion technology. This is the seventh lecture. So we have already discussed so many things about extruders right now. What are the extruders and its type, its engineering properties, and how to nomenclature it, and some calculations also we practiced. So now the last part, not last, but the other part of this lecture series, it's about raw materials and processing. So at the end of the day, we will discuss about quality assurance. So we have around two more lectures regarding the extrusion technology. So today I'm going to discuss with you some further details about the raw materials and processing conditions. So I hope that you can remember the things we have discussed in the last week about the raw materials, and basically what type of raw materials we can use for extrusion. And before moving forward in the extrusion process, dough preparation is very important. So it means we just mix some ingredients together, and with water, like any solvent and liquid, basically we use water. And water, chill water we can use, hot water or normal water. There are different stages of water, and we can use those different water with different temperature according to the applications, right? And how to manufacture pasta, we have discussed the detailed process. And composite flour mixtures also, what is composite flour mixture. Basically, as an example, some portion like three portions, some portion like flour varieties, we call it as a composite flour mixture. So basically there are different types of flour. And when it comes to raw materials, so we have discussed these things last week also. So I just wanted to remember some points, because we are moving towards for some new moving to discuss some new area today. So therefore it is important to remember the raw materials, and basically we use starch and flour, and especially carbohydrate based raw materials we are using. And expansion is very important when it comes to extruded food products. There are expanded and unexpanded products. So expanded products is they have very big market demand, expanded food products. So it is actually a very popular type of food products. And to get the proper quality expanded food products, it is very important to maintain processing conditions and also the conditions of the raw materials as well, right? And here you can see some, as we discussed, wheat and rice are the widely used raw materials in Asian countries, right? So roots, we have roots, so many roots in Sri Lanka, but nutrition value is a problem. So we can do some fortification process after develop the extruded food products. Then about when it comes to composite flour mixtures, here you can see some mixtures: corn, cassava, potato starch, and kurakan like materials also we can use, right? So to improve its physiochemical properties and sensorial properties, and also nutritional characteristics. So the major problem of the extruded food products are nutritional problems. So it is actually just a food product with very good sensorial qualities, but nutrition is not there in an adequate level. So therefore, we can do some value addition by impregnating or by incorporating some nutrition, right? And composite flour mixtures we can use to get a good expanded food products. It means to get a proper quality food product. But basically we use starch and flour. Most commonly we use wheat flour and wheat starch in Sri Lanka, right? There are different types of extruded food products: meat-based products, fish-based products, and how to develop composite flour mixtures, and how to mix different types of raw materials together, right? Here you can see the first example, fish and wheat flour, right? How to develop different types of cereals and fish-based raw materials. And the product you can see extruded fish and raw, right? Then the second example you can see it's type of crab, and we are going to mix with corn and potato flakes. And at the end of the process, you can get extruded stack. Right? Likewise, there are so many examples are available in the books, and also you can get from the internet also, and by referring to some industries also. So different types of food products are available by using different raw materials. But in Sri Lanka, we are using only wheat flour, like flour and starch varieties. So that's why still we have very good demand for extruded food products, but we can go further, right? So the feeding is very difficult problem in nowadays, feeding to children, infants. So it's very difficult. So you can develop such interesting food products with proper nutrition values, right? It's very important to have a look on this type of research-based details. Then you can get. You don't want to remember, but just a look and just have a look and identify and even read the names, right? Potato starch, and you can use here. We have sweet potato in Sri Lanka, so likewise different types of raw materials. You can use oats and tapioca, means manioc, rice flour, and soybean flour together with fish-based products. So you can see how many products are available in the market by using different types of raw materials here. I have taken, I take this literature from Springer. It is a very good source, so reliable source. So you can see here also, here around more than 20 products are available, right? One paper. Okay, it's very important. Right? It's very, very important for you to develop your own food product by incorporating different types of raw materials. Right? Preconditioning also a very common word. I think you can remember this word. We have discussed this word in different slides in different lectures. So today I am using to give you some technical details regarding preconditions. Preconditioning. So scope of the preconditioning is to facilitate the extrusion process. So extrusion process is there, extruder is there. Before that, feeder is there. We need to feed the raw materials together, and in some extruders you can see while processing some raw materials, then you can add other raw materials to directly to the barrel, right? So preconditioning, like as we discussed, some chocolate like raw materials, it need melting, right? So we have to melt it before processing, as an example. So likewise, like the processes, so we need to have different preconditioning systems, right? We can increase the temperature, we can add moisture, we can add steam, and blanching also possible, right? Different types of processes are there to complete before extrusion, right? Here you can see the temperature. Basically, we use 80 to 90 degrees of Celsius here. Celsius, this is Celsius, not 900, right? And some examples for pasta manufacturing, some breakfast cereal manufacturing, we need to have a good preconditioning system, right? TVP means texturized vegetable protein. It's a sort of a soya-based product, and some meat-based products also we need to have a preconditioning system, right? And there are some single and double shaft preconditioners, right? If we have what are the shaft? So if we have a double shaft preconditioning system, it is more effective than the single shaft one, right? To get the uniform product, uniform raw material mixture before sending to the extruder. So as a result of installing this type of preconditioning system, proper system, so the process efficiency also will be increased. You can see how to implement a preconditioning system, you can fix it here or here based on your requirement. Then in this extruder, this is the feeding tank, feeding point. So that's why they have developed this machine like this. So based on your parameters and properties of your extruder and requirements of your process line, so you can install and you can design your own preconditioning system according to the requirements. It holds raw materials in warm, moist environment and must be flowable raw materials, right? And pre-gelatinization, right? Pre-gelatinization is important, right? But pre-gelatinized starches cannot be preconditioned, right? That's important. So technical details are there. Advantages, I think we have discussed to increase the life of wear equipment. It means durability of the equipment, increase the output, improve the product quality with regard to sensory attributes, and avoid the externalization and reduce the retention time. Right, you can get it quickly. So, so I'm going to move to the very important parts of today's lecture. I hope you have very good understanding about these parameters. So today I'm going to discuss some technical details with you, right? So you know theories, you know how to use an extruder, what are the parameters, all these things you know. But technical details are very important. How to maintain the factors together, and how to increase and how to analyze its relationships. Right? The time and temperature, pressure, retention time, those things are very, very important. Right. So therefore, it is you need to get an idea about the consequences and the how to affect those factors in the process. Right? In this picture, right? In this picture, there are two diagrams. I have copied this diagram from this reference. You can see the reference here. It's one of the very famous, very good, reliable source. So you can see 3D diagrams, two diagrams. In the first one, A, this axis specific energy. This one moisture content and extrusion temperature, right? So by referring to this diagram, it is very easy to understand when we increase the temperature, right? In this end, you know, you can see the temperature is around 105 degrees of Celsius. Here 175, it means the temperature have been increased from here to here. Then what happened to the sorry specific energy? Here you can see somewhat higher. It's close to minus 500, right? Somewhat higher one. When we increase the temperature, then what happened to the specific energy? It has been reduced, right? And what happened when we increase the moisture content for a particular temperature? Here you can see 105, and we have increased it. We are going to increase the moisture content from 21 to 30. Then what happened? Right? You can see the energy deviation from here to here. Ne? From here to here increase, then there is a peak point, then it has been decreased. Right? When we in the next one, diagram B, this is very important, right? Here there are three factors again: extrusion temperature, moisture content, and expansion index. Expansion index is very important for us in developing expanded food products. So how to change, how to deviate the factors and the effect, how to affect these factors together, right? Here again you can see the temperature from here to here. We are going to increase the temperature. With the temperature and expansion index, you can see somewhat around 1.01 to 1.63. So it means it has been increased. So here to here, at low moisture, here the moisture content is 21. So we are going to increase the temperature at 21 degrees of, we are going to increase the temperature at the moisture content of 21, right? Then you can see here, from here to here, what is happening? Expansion index has been increased. So it means we can conclude at low moisture content, when we increase the temperature, what happened to the expansion index? It is also increasing. When we increase the temperature at low moisture content, by maintaining the low moisture content, means low water content, then what happened? Expansion index also increased. Right? Number one. But here what is happening? You can see expansion index is it is maximum here. It means the moisture content is high value. It's around 30%. So you can see when we increase the moisture content at low temperature, right? Here you can see the temperature is around 105. Then what happened when we increase the temperature? What happened to the expansion index? It has been reduced. But here you can see when we increase the temperature, expansion index also increased. But here, when we increase the temperature, expansion index is being decreased. Right? What is the major difference? Here you can see we did this process at low moisture content. But when we increase the moisture content, what is happening? With the temperature, expansion index has been reduced. Right? It is very important. And here to here, from this end to this end, it means when we increase the moisture content at a unique temperature, it means the temperature is around 105, and we are going to increase the moisture content of the dough mixture. Then what happened? What happened? From here to here, expansion index has been increased. At low temperature, we are going to maintain the low temperature here and increase the moisture content of the dough mixture. Then what happened? Ultimately, expansion index also increased. Right? At high temperature, you can see what is happening with the moisture content. When we increase the moisture content at high temperature, you can see it is there is a increasement and also decreasement. So what I wanted to explain here is temperature and moisture content is very important, and when we use these two factors together, then you can see how it occurs. How those factors are affecting for the expansion index, right? This is very important, so you have to remember these things strictly. You have to remember. So in your paper also, I am going to ask some questions by using this type of technical detail. So you need to remember the theory. So what is happening? Right? Not need to remember this graph and this picture, just to remember the theory and the technical importance of these pictures. So here you can read, I have explained all these factors one by one. I have explained in the previous slide. So if it is not clear, then you can read it again. Right? And there are two more factors. Evidently, properties such as expansion are dependent on the above mentioned factors, which correlated with the degree of gelatinization and composition of the mixtures. That's true. Besides, the behavior of the expansion index could be correlated with fiber content, and also fiber addition minimize the expansion of cereals. What will happen when we increase the fiber content? So expansion will be decreased, right? So if you are going to select a raw material with high fiber content, for expanded food products, extruded food products. So you have to rethink how to do it, right? Then you can mix some ingredients together, right? I have uploaded an assignment, very good assignment for you all to write a technical report. So for that report also, you have to follow these guidelines, right? Also, when increasing feed moisture content, it means moisture level, it results products with high density, low expansion, high water absorption index, lower water solubility index, and high hardness, right? You can read these things. I'm not going to explain. It's very easy. And after increasing the barrel temperature, it means when we increase the temperature inside of the extruder, expansion also increases of the extruded, but it results for reduced density and increased water solubility index. So what is happening when we increase the temperature? Expansion means removal of inside water. As a result of the big pressure difference, then what happened? Immediately, the water molecules inside the food will be evaporated as steam. So as a result of that, the food is getting expanded and the density will be reduced. So you know these things, right? An effect of temperature and pH, as we discussed, the nutritional value of the extruded food products are very low. So as a result of the high temperature, so in basically the antioxidants and polyphenolic raw material, polyphenolic compounds are very important. They are health beneficial active ingredients available in the raw material. So, but when we increase the temperature and the pressure, as a result of that, then what happened? What happened? Those polyphenols and antioxidants will be denatured and evaporate. So, the maintaining high temperature is a little bit critical, but nowadays you have some technological knowledge. So then we can go for nano encapsulation and nanotechnology. We can use some nanofibers together with the extruded raw materials. Then we can prevent the nutritional value, right? So do not think on the traditional extruded food product extrusion industry. So now you are technologists, then you can think how to add value, how to do this extrusion by incorporating the technological knowledge, right? So as I discussed here, then nutrition losses they are with high temperature. Then what you can do is there are so many options. So one option is you can develop a new polymer, right? New nano material, then with high heat resistance. Then you can mix it with your raw material. Then what is happening? There is no more loss, right? There are so many technical solutions are there. So you need to understand these technical solutions and get updates from the internet and reading books, right? Okay. Effect of pH. I suppose you can remember the first day also I discussed pH is very important to maintain the quality of extruded food products. Sometimes we add citric acid to the dough mixture to get a quality product. If not, sometimes you can see the breaks and the peel outs of the extruded food products. In pasta and noodles, the texture is very smooth. The outer texture is very smooth. It is also very smooth. But sometimes when we change the pH and the temperature, then what's happening? Peeling like texture changes will be there. So these factors are important to maintain. Yeah, I put some bioactive compounds available in food raw materials. right? There are some examples. So you can, you need to understand and you should have a knowledge about the antioxidants available in some food items, right? In grains and vegetable foods. So I hope that you have studied these things before. So then before using these different types of raw material, it is important to highlight their nutritional value and health benefits and also its effect on the entire production line, how it affects, right? So you can understand, you can discuss these like the bioactive compounds and highlight what type of bioactive compounds we are going to use in this type of extruded food products, right? And starch is one of the most common one. You know, amylose and amylopectin is very important, right? Amylose in the basically in starch, it's around 20 to 30%, and amylopectin is 70 to 80%. So you know, amylose is sort of a straight molecule polymer, and amylopectin is somewhat a branch one. So we have discussed that amylopectin can absorb more water rather than absorbing water to the amylose. So as a result of that, amylopectin will grab and will absorb more water, and it will gelatinise easily, right? But as a result of the structure of amylose, it is hydrophobic. It means the amylose doesn't like to absorb water, but it will create some bonds with fatty acids and lipids, right? So if we have more amylose, in our raw materials, so it is very difficult to absorb water. So as a result of that, you know, gelatinization is there. So gelatinization means absorb water and change the texture with the temperature. So if amylose is hydrophobic, helix is hydrophobic, so therefore it will create bonds with fats, not with water. So therefore it is very difficult to develop extruded food products with high amylose content. So there should be high amylopectin content than the amylose content. As a result of that, gelatinization temperature, viscosity may alter. You know, as I discussed earlier, low gelatinization temperature for food with amylose, right? Low gelatinization temperature for food with low amylose content, right? Low amylose content. If we increase the amylose content, you can see it is hydrophobic, so therefore gelatinization temperature will also be increased, right? Normally, amylose-rich starches showed higher viscous and less Newtonian behaviors, and also higher gelatinization temperature. We have discussed, right? And amylose and amylopectin percentages of some starches, you can see almost all the starches, amylose content is lower than amylopectin contents, right? Banana, you can see it's around 70 to 84 amylase. It's somewhat similar to corn, potato, and right? So you can see the amylose and amylopectin levels here, right? You can use these details in developing your own food products, right? So here, but corn, type of corn, you can see the amylose content is a little bit higher. So it is very difficult to use this type of high amylose corn. So if we use this type of corn, then what happen? What will happen? Utilization temperature will also be increased. The water holding capacity is very low. So you know we can't use this type of raw material for expanded food product neither, right? And amylose contributes for gel formation, and amylopectin contributes for viscosity. So you know amylopectin will absorb more water, right? More water, and as a result of that, viscosity will be increased. But amylose, it will develop some hydrogen bonds, some bonds with fatty fat and fatty ingredients and materials available in the raw material mixture. So as a result of that, it will increase the gel formation, but not for the viscosity. So if you need more viscous raw material mixture, so what you have to do is use more raw material, use more amylopectin, right? So amylose will help to get either more crispy or expanded extruded, right? Amylose will help to get more crispy and expanded extruded, right? But this is dependent on the temperature. You know, amylose will absorb low amount of low percentage of water. So, so what we have to do is increase the temperature. And amylose rich raw materials provide more expansion than amylopectin rich raw materials in extrusion. Also improve cutting and shape retention after extrusion, right? Amylose rich raw materials provide more expansion than amylopectin in extrusion, but cutting and cutting shapes also improve, right? High amylopectin content of starch absorb more water, gelatinizes easily, increase the stickiness, but difficult in stickiness and difficult in cutting. So you have this experience with some rice varieties. When we are cooking such rice varieties, it will absorb more water, right? And the texture also not good. So therefore, rice cooking means also a type of type of a gelatinization. So therefore, you can get the hands-on experience by using by changing the water levels for with rice, and then you can get the out. You can determine the quality of the output. Right? Actually, a home practical. This practical you can do in your home. Okay. Most of the flavor compounds are fat based and tubers. So you know these things. So I'm not going to read, right? So and finally, amylose helix structure is, you know, amylose is hydrophilic or hydrophobic. As we discussed, amylose will form bonds, hydrogen bonds with fat. So it's hydrophobic. Therefore, form chemical bonds with fat molecules. As a result of starch lipid complexes, what will happen? Viscosity or here gel formation. It forms or gel, neither amylopectins and motivate for, and we have to provide more temperature, right? It's higher temperature. Tuber starches versus grain starches. So what are the differences between tuber starches and grain starches, right? You can get the reference values for amylose and amylopectin and its protein content, its fat content, right? You can refer these details in by referring to the internet. So then you can determine its expansion index, the water requirements, water holding capacity, everything you can discuss. So please do these exercises after studying this lecture. And in fact, here you can see granules of different types of raw materials. You can see different granule shapes. Right? Granule shape is again very important. You know the effect of granule size and hot absorption capacity and get a smooth product. So granule size is very important, right? Here you can see some pictures and relationship between granule size and gelatinization temperature, right? Granule size and gelatinization temperature. Right? When we increase the granule size, so it means the raw material with high granule size volume, then what happened? The surface area is comparatively low. So it means we have a very low granule size, then the surface area is comparatively higher than large granule raw materials. So it will absorb water easily. Then what happened? The process will also, gelatinization temperature will also be reduced. So those are the differences, right? You can think and write the answers for these questions. Effect of other hydrophilic ingredients. Hydrophilic means hydrophilic means it will react with water. It will absorb more water, right? Then what happened? Can you remember the graph we have discussed? With more water means we have to use more water in raw material mixing, even in preconditioning and extruder, inside the extruder. Then what happened? Right? With high amount of amylose and amylopectin. With high amount of amylose, what is happening? With high amount of amylopectin, what will happen? Right? Please give your answers for these questions. Right? With more fat and fiber. Right? I have discussed all these things. So you can answer to these questions effectively, right? Final product quality, you can see the quality parameters, right? This is just an study. You can here you can see some samples they have prepared and against quality parameters. So the parameters have been changed for the samples. So in your production line also, when we start the production line, then we can do more experiments. And two more questions. Sprouted grains. Sprouted grains. What is happening when sprouting? What happened to the starch content? What happened to the fat content? So you can study. Right? When sprouting, you know, sprouting means, well, you know what is sprouting. So with the time, it will absorb water and starch conversion is there, sugar conversion is there, amount of fat also will be changed. So as a result of that, what will happen? What would happen? So you can see, you can take two samples, mung bean, first one, normal mung bean, and the second sample with mung bean starch obtained from sprouted mung beans. Then what will happen? What would happen to the final product quality? So you have to think on these things and discuss the results. Maturity levels of the grains. Maturity levels of grains. So that is also with the maturity level also, its fat, its starch and flour content will be altered, and the fat content, protein, everything will be changed with its maturity stage. So less maturity, medium maturity, and high maturity, and correct maturity, you can think, right? There are so many details available in the internet, and you can get what is happening with the maturity. So by referring to the details you get from the internet, then you can answer to these questions. What will happen to the final product quality, right? So today I'm going to wind up the session with this, right? And we have discussed very important things today, basically about raw materials and some processing parameters. And preconditioning is, it is very important. and its advantages and the parameters we are going to maintain in this stage. And temperature, moisture, particle size, oil content, amylose, amylopectin percentages, and flour mixture, how to use a flour mixture. Different types of entirely different flour mixtures also we can use. So how it change. And in these two graph, we also discuss about the specific energy, extrusion temperature, moisture, and expansion index, how it change with different factors and with by altering two factors together, right? Effect of temperature, pH, and everything we have discussed. So I suppose that you all can use the raw material. So before using raw materials, it is very important to study the its maturity stage, its color, its variety, its flour and starch composition, moisture composition, fat level, everything you need to understand, clearly study. Then design the process and design the product whether it is a puffed one or normal product, whether it is a ready to cook one or ready to eat one. So likewise, that's the process. Right? If sometimes you just take some ingredients and mix those things and try to develop extruded food product. That should not happen as you are technologist, right? Before that, everything has to be planned. The process line, raw materials, quality, everything has to be planned and go for the process, right? And today you can see some technical details. So there are some questions you have to answer all these questions. And if you have any doubt, any clarification, please contact me for in answering these questions. So I'm not going to give answers because I have discussed all these things with you. So you can comment on these questions, right? Okay, then thank you very much, and please go through the lecture and the video, audio, and please download the assignment 2 guidelines. It's actually a little bit complex assignment. So please download it now and carefully read it and highlight the things which you have to highlight, right? And start it. Please do not finish it. Just start it and think on how to do it and plan it. You have 2 more lectures. So after completion of 2 more lectures, you can finish that assignment. So before that, do not finish it, right? Just have a look and get an idea, right? Thank you very much and have a nice day.